Hi and good day everyone. Welcome to Hosey How To channel, where I share real project experiences for better skills that will lead to higher pay career. Today, I would like to share with you an interesting topic: variable speed pumping system. In most of the pumping system, a pump is operating under a constant speed to deliver flow to a demand area. The constant speed of the pump is normally similar to the motor speed. However, a variable speed pump is a pump that can run at a different speed to suit the specific flow requirements. In today's session, we will discuss the following of variable speed pumping system. 1. How to vary the pump speed. 2. The reasons and benefits of variable speed pump. 3. How to achieve the desired pump speed. 4. What are the points to consider when applying variable speed pumping? Before we proceed further, please subscribe and like my channel by clicking subscribe button. Let's get started. Electric motor is the driver for a pump and is normally directly coupled to the pump. Hence, the pump speed will follow the electric motor speed. In this case, the number of poles of the motor will determine the motor and pump speed. For example, a 2-pole motor will have 3000 revolutions per minute speed, while a 4-pole motor have a 1500 revolutions per minute speed. In order to vary a motor speed, we need to use a variable frequency drive, VFD, to adjust the motor speed. A VFD is a device that controls the speed and torque of the motor by varying the frequency of the input electricity. The power supply frequency is normally ranging from 0 to 50 Hz. Theoretically, you can adjust the motor speed from 0 to 1500 revolutions per minute if it is a 4-pole motor. However, in the industry, the minimum motor or pump speed adjustment is limited from 50 or 60% to the full speed only, depending on pump manufacturer design. As a rule of thumb, a 60% minimum speed is a safe figure for both motor and pump. The main benefits of variable speed pumping system are as below. 1. Energy and money savings. As the pump operating at the optimum efficiency point, the adjusted pump efficiency and power curves is shifted to the left side accordingly based on the lower speed and flow demand as shown. However, the pump is still operating at its optimum efficiency but with a reduced power. This will reduce the energy consumption and save the operating cost tremendously. 2. Flexibility and improved process control. The variable speed pumping will vary the flow delivered by the pump. This is the main advantage when a pumping system need a wide range of flow demands in the operation. The pumping station will be very flexible to deliver a wide range of flow with lesser number of pumps. In addition, the variable speed will meet the demand accurately with the exact flow speed adjustment. This flexibility will allow the same pump to operate at lower flow during an initial startup of a system where the consumption is much lower. 3. Improved system reliability. The equipment will have a high system reliability than they are operating at a lower speed. The low-speed operation will reduce the wear and tear and hence prolong the lifespan of the equipment, such as bearing, wearing rings, impeller, mechanical seals and etc. The maintenance and downtime of the pumping system will be greatly reduced. Now we know that the frequency can be adjusted and set to the speed we needed. But how do we adjust the speed of the pump to the required flow demand? This can be achieved by using the affinity laws to express the relationships between variables involved in pumps such as head, flow rate and their speed, where Q is the flow, H is the head, P is the power, N is the speed. With the affinity laws, the variable speed curves can be generated using a spreadsheet. You will need to obtain a pump performance curves from the manufacturer and specify the desired pump speed in the spreadsheet. The variable speed curves will be plotted automatically. Their system characteristic data is another data to be inserted. Please check the link on top on how to calculate the system characteristic curve from pump sizing calculations in my other video. If you want to use the spreadsheet to generate the variable speed curves, click on the link that I have provided at the end of the description. You will note that the pump flow, pressure head and power is reduced or increased with the ratio speed with the power of 1, 2 and 3 respectively. Therefore, the power consumption will be greatly reduced with the power of 3 if we can reduce the speed. In the long run, this will be a huge saving to the operation costs. So, What are the points to consider when applying variable speed pumping? When applying the variable speed pumping, the following shall be considered. 1. Range of variable speed as indicated earlier. The minimum speed shall be considered 50 to 60% of full speed due to the pump and motor design. Too low a speed for pump will damage the pump as it is running out of the allowable continuous operating range. In addition, the low-speed motor will cause insufficient ventilation for heat dissipation and cause the motor to trip due to overheating. 2. Flat and steep system curve. The system curves will have great impact to the use of variable speed operation. A steep system curves is ideal for VSD control. The ratio of flow versus speed will be very linear and flow control will be straightforward. Conversely, with the flat system curve, variable speed pumping may be difficult. A small speed change may result in a dramatic change in system flow. 3. Flow velocity. For self-cleansing. As flow decreases with a VFD, the flow velocity in the piping decreases. If the velocity falls below the recommended self-cleansing velocity or minimum solids carrying velocity, system becomes susceptible to sedimentation in the line. That's all for today. I hope you've learned something on the variable pumping system in today's video. Please subscribe and like my channel. Thanks for watching.